So today we're going to review simplifying radicals because you're going to need it in the next lesson that we do. So this is from pre-algebra and also algebra 1-2. So my suggestion as you're trying to simplify these radicals is to prime factor every number that's underneath here. So we're going to start with a prime factor tree. And it doesn't matter, you choose any two numbers that multiply to give you 24. I personally wouldn't start with 2 and 12. Choose some bigger numbers like 4 and 6 or 3 and 8 and keep going until you get a prime number. So 4 and 6 are not prime. So we get 2 and 2, those are both prime. And then 2 and 3. Those are both prime. So then let's rewrite this so that it is 2 times 2 times 2 times 3. And because we have a square root, it's understood that the index here is a 2. Because we have a square root, we're looking for groups of 2. So I have a group of 2 right here, and I'm going to take that out of the radical. And so essentially, isn't that 4? 2 times 2 is 4, and isn't the square root of 4 2? And so when I take that out of the radical, only 1 2 is going to come out in front because the square root of 4 is 2. And then you are going to multiply whatever's left over that didn't make a group of 2, and that will go underneath the radical. And so since 2 times 3 is 6, 6 stays under, and this becomes your simplified radical. So that was a square root, so let's look at a cube root. So this time I'm going to split out the negative from the number 162. And then I know that 9 goes in here because 1 plus 6 is 7, 7 plus 2 is 9, and so I know 9 divides into there. So 9 goes into 16 once with 7, so it should be 18, and then 9 becomes 3 and 3, and then 18 becomes 3 and 6, and then 6 can keep going to 2 and 3. So for my cube root, I'm going to put a -1 underneath here. We'll talk about how we deal with that in a minute, times, and then I have 1 2, and then I have 4 3s. Okay, so because my index here is a 3, I'm going to be looking for groups of 3. So I only have one group of 3, which is right here, but I can also take the cube root of this -1. So this -1 I actually could have written, and here's the great thing about negatives. You can take an odd root of a negative number, and it's always going to be negative. You cannot take an even root of a negative number because there's no way to take a negative and multiply it by itself an even number of times and get a negative value. But here, I can actually convert this -1 into, I can put 3 -1s under here. Couldn't I make this into -1 times -1 times -1? If you take -1 times -1, that's +1. +1 times -1 is a -1. So I can put as many negatives down here as I want to as long as the value turns out to be negative. And lo and behold, I now have a group of 3. So out in front, this will be our equal sign. Out in front, we're going to have a -1 times, and then we're going to bring out just 1 3. So every time you have a group of whatever your index is, in this case our index is 3, you just take one member from that group. And then we are going to multiply the two numbers that are left underneath. So we have that 2 times 3. And so a -1 times 3 is -3. Cube root, oops, I should have put a cube root on there. And then 2 times 3 is 6. So this becomes our simplified radical for that cube root. Now we have a fourth root. So I'm going to prime factor the 128. And I know this time that 4 goes into 128 off the top of my head. So 4 goes into 12 3 times, 4 goes into 8 twice, 4 is going to be 2 2s, and then 32 is going to be a 4 and an 8. So that 4 is 2 2s, and hopefully by now you know that 8 is 3 2s. So 128 is made up of purely of 2s. So there's a lot of 2s here. I'm going to show you a shortcut that we're going to use with our variables, and so this might be a perfect time to go to that shortcut, but I'm going to do it the long way at first. So I have in total 1, 2, 3, 4, 5, 6, 7 2s. This is becoming quite cumbersome to have to stretch out 7 2s. And then one more. And then we have this n to the 8th. Who wants to stretch that out? Not I, but we'll go ahead and do this. Now that's truly a pain. So I'm going to show you a shortcut here in a minute, and we're going to try that with all of our stuff here from here on out. So I have a 4th root this time, so I'm looking for groups of 4. So I'm going to circle groups of 4. There's one group, and then I don't have enough left over, so I'm going to multiply those together. And then as far as my ends go, there's one group, and here's a second group with no ends left over. So I'm going to bring out in front of the 4th root 1 from each of these groups here. So I'm going to bring out 1 2, 1 n, and a second n. So I have 2 times n times n, and then underneath my 4th root is going to be that 2 times 2 times 2. All right, so then I'm going to multiply everything together, and then I get 2 times n is going to give me 2n to the second. And then I have the 4th root of 2 times 2 times 2 is 8. So here is our answer, our simplified 4th root. Now, here's what we're going to do for the shortcut. So for the shortcut, let me put a line through here. Instead of stretching everything out, we're going to put everything into exponential form, and I'm going to prove to you that we're going to end up with the same answer. So we're going to start off with everything in exponential form, and we've already done the work for this. So 4th root of, so remember I have in total 4 plus 3, so I have 7 2s, so 2 to the 7th, times, and then I have this n to the 8th. So the shortcut would be to take your index and just divide it into each of these. So I'm going to take this index right here, and I'm going to divide 7 by 4 and divide 8 by 4. So the whole number that I can divide this by comes out in front. Since I can divide 4 into 7 one whole time, then I get 1 2 that comes out in front, just 1 2. And then underneath that 4th root, when I divide 4 into 7, 4 goes in there once with 3 left over. So that means I'm going to have 3 2s left underneath the 4th root. Then over here, 4 goes into 8 evenly twice. So because 4 goes into 8 twice, I'm going to have an n to the second because 4 went into 8 twice. There are no remainders, so there are no n's left underneath here. And wouldn't my final answer for this be this right here, for this whole thing? Wouldn't I still get the 2n squared? Here's your 2n squared. 2 cubed is 8. So we're going to enlist that shortcut rather than stretching everything out. You can stretch things out, but you can see how long this is going to be. And what if this were 32? Who wants to stretch out 32 variables? So now we have a fifth root, so we're going to prime factor 224. And off the top of my head, 4 goes into 224. So 4 goes into 22 5 times with 2 left over, and 4 goes into 24 6 times. 4 breaks down into 2 and 2. And then 56 becomes 7 times 8. And we already know that 8 has 3 2's. So this time we're going to write everything exponentially. So I have the fifth root of, and then I have 1, 2, 3, 4, 5 2's. So 2 to the fifth times, and then I have 1 7. So we are going to take this index of 5 and we are going to divide each of these by 5. Well, since the exponent of 7 is 1, if you try to divide 5 into that 1, it doesn't even go any times at all. So here's what happens. So remember, however many times that 5 divides into their whole is how many 2's come out. So because 5 goes in there once with no remaining, we have 1 2 that comes out. So we have a 2 that comes out in front of the fifth root, and no 2's are left underneath. Then here the 5 doesn't even go in there at all, so there's no 7's that come out. And then this is the only 7 that remains. So you do have a fifth root of 7 underneath there because we have nothing to match it with for a fifth root. And so that's your simplified version of that one. All right, so then I want you to try number 9 on your own and see how you do, including the variable. So pause the video, try number 9, and then restart the video. So off the top of my head, 4 does go into 392. So I'm going to start with 4. 4 goes into 39 9 times, and that's 36 with 3 left over, and 98. I'm just going to check my math, make sure I didn't do that wrong. So 392 divided by 4, awesome, it is 98. Okay, oops, I don't know why I put a circle around the 4. It's not prime. So then the 4 breaks into 2 and 2. And then the 98 is divisible by 2, and we get 49, 2 and 49. So the 2's prime, but the 49 becomes 7 and 7. So then I'm going to write everything exponentially. So I have 2 to the third, and times 7 squared, times x squared. So it is understood that your index here is 2. So I'm going to divide each of these by 2. And 2 goes in here once with 1 2 left over. So I have a 2 out in front. And then underneath the square root, I'm going to have a 2 left underneath there. But with the 7, 2 goes in there evenly once with no 7's left over, so times 7, whatever comes out in front gets multiplied to each other. No 7's left underneath. And then 2 divided by 2 is 1, so there's 1x that comes out in front, no x's left underneath. So if I were to multiply that out, 2 times 7 times x is 14x, square root of 2. All right, you try 11, 13, and 15 on your own, and then restart the video, and then you can check your work. All right, so for 405, I know that 5 goes in there, and 5 is prime, and it goes in there 81 times, and then 81 is 9 and 9, which is 3 and 3. Okay, so exponentially, I've got 3 to the 4th times 5 to the 1st, and there goes lunch.
Lunch is over.
Okay, so then this is our index is 4. So I'm going to divide that by 4. 5 doesn't have it, well, it has an index, or it has an exponent of 1, and I know 1's not divisible by 4. 3 is not divisible by 4, and 2 is not divisible by 4. So the only item that can come out in front is the 3. Everything else here will be left underneath because 3 and 2 are not divisible by 4. So 4 divided by 4 is 1 with no items left over. So we are definitely going to have a 3 out in front of the 4th roots. And then underneath is going to go 5 x cubed y to the 2nd. That's it. Only one of those things could simplify. So you weren't crazy. Maybe just a little bit. Just a little bit crazy. Okay, so the 128 is divisible by 4. And we have already done this before, so it's 4 and 32. And of course the 4 is 2 2s. And the 32, when we did this earlier, is 5 2s. 1, 2, 3, 4, 5. I'm not going to circle those. You get the idea. All right, so the 4th root of 1, 2, so we have 5, 6, 7, so 2 to the 7th. And then x to the 7th, and then y to the 7th. So this one, we're going to take this 4, and all of them can be divided by 4, divided by 4, and divided by 4. So 7 divided by 4 is 1 with 3 left over. So we're going to take 1 from each of these out in front, and 3 are going to be left over. So out in front is going to come 1, 2, 1x, and 1y. And then underneath the 4th root, we're going to have 2 to the 3rd left over, x to the 3rd left over, and y to the 3rd. So we still have to multiply everything together. So out front, 2 times x times y is 2xy. You don't want to leave any of those multiplication symbols out front. And underneath, 2 to the 3rd is 8, x to the 3rd, y to the 3rd. That's a 3. Hard to tell. Okay. And so this is your simplified version for number 13. And then for 15, 448, I know for a fact 4 goes in there. 1, 1, 2. And I know 4 goes in here again. And we get 28. So I get 2 and 2, and then 4 and 7, and then this is 2 and 2. Okay, so I write everything exponentially. So I have 1, 2, 3, 4, 5, 6 2s. So 2 to the 6th times a single 7, and then x to the 7th, and y to the 7th. So here's my index. I'm going to divide that by 6. The 7 cannot get divided by 6 because its exponent is 1. 6 can't go into 1. But x to the 7th, that can be divided by 6, and so can y to the 7th. So for this one, 6 goes into 6 once, so 1, 2 comes out in front. Do my 6th root here. No 2's will be left over because 6 goes in there evenly. For this one, nothing comes out in front, so we're going to leave the 7 underneath. For this one, 6 goes into 7 once with 1x left over. So 6 goes into 7 once, so 1x comes out in front, 1x is left over. If you want to stretch out 7 x's, you can group up 6 of them. And so 6 leave, and you put one of those x's out in front to represent the group, and the leftover x's underneath. Same thing happens with the y. You get one y out in front and one y left over. And so that is your fully simplified answer. Okay, so then our last question is, So this last question, they just want to know, they want you to actually go backwards. So this is your answer right here. And they want to know, what did you start with to get to that answer? So if our index is 3, that means we must have had 3 2s underneath here to bring out 1 2. So we had to have one group of 3 2s, one group of 3 m's, and one group of 3 n squareds. So underneath our cube roots, and I'll show you a shortcut to doing this in a minute, means that here, in order to have 1 2 come out in front, I must have had 3 2s underneath there. And then we have this 5, so I'm going to leave that 5 underneath there. And then for the m's, we must have had 3 m's underneath here. So M, 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 right? And then we have this 1 m left over. So there's another m underneath there. And then we would have had to have 3 n squareds. So n squared, n squared, n squared, and then we have a single n squared left over. So that's one way that you could do this. Then we're going to simplify. So 2 times 2 times 2 is 8. 8 times 5 is 40. So this would be 40. And then 1, 2, 3, 4 m's. So that would be m to the 4th. And then 2, 4, 6, 8 n's. So n to the 8th. So that's what we must have started with. Now, the shortcut to this, if you care to know, wouldn't we take this whole thing outside and raise it to the 3rd power? So we're going to take 2m n squared, and we'll raise that to the 3rd power. And then you would multiply it by what's underneath, 5m n squared. And all of this would go underneath the cube root. So power to power means you multiply. You would take this and multiply it to each of those exponents, okay? So you would get 1 times 3 is 3, so you get 2 to the 3rd. And then 3 times 1 is 3, so m to the 3rd. And 3 times 2 is 6, you would get n to the 6th, which is these 6 n's here. And then, of course, you have a 5, there's your 5, in m, there's your m, and then an n squared, there's your n squared. And then you could just multiply those together and get what we got here. So your homework is to complete the evens. So you have 9 problems. Good luck. Text me if you have questions.